Hello grade 12s. Today I want us to look at a question in trigonometry which is proving identities using compound and double angles. So where we're going to prove that our left hand side equals to right hand side. Right, before we start with our questions, let's first look at the steps that we need to use before we answer this type of question. So we're gonna go use our platinum textbook to look at the steps. Right, it's page 101 of platinum, which is proof identities using compound and double angles. So these are the instructions. It's on page 101. The first instruction, I'm just going to look at the first one and then we'll be using the steps when we answer the question. Ensure that all the ratios are in terms of sine and cos. So meaning that we have to change tan x into sine x over cos x. So let's look at the question. Right, the question is, prove that 3 minus 2 sine squared x divided by 2 sine x times sine 90 minus x equals to 1 over sine x, cos x sine x plus tan x tan 2x. So if you look at the question, from our left hand side, look at this. We have sine 90 minus x. And we know that sine 90 minus x equals to cos x. Therefore, we can start by saying that left hand side equals to 3 minus 2 sine squared x over 2 sine x cos x. Right. Then when I look at my left hand side, right, I think that we don't have to prove this further, because if you look at the left hand side, it's not more complicated, it's less complicated. Right, so we leave it as it is and then we go to our right hand side. Right hand side equals to, if you look at your right hand side, right, we have tan 2x. And if we go back to our instructions or our steps, right, it says that we must ensure that all our ratios are in terms of sine and cos. So this is where we're going to change our tan into sine over cos. So therefore we'll have 1 over cos x sine x plus 1 over sine 2x over cos 2x, which is this one. Right. Then from there, we continue with our right hand side because it's still more complicated. Then we write 1 over cos x times sine x plus, then this is a fraction over a fraction. So we write it as cos 2x, no, not cos 2, yes, cos 2x over sine 2x. Right, here we've tried to solve this one because it's a fraction over a fraction. Then from there, we continue to look at our instructions. It says that we must change all double angles to single angles so that you are working with ratios of one angle. Therefore, we can change our cos 2x and sine 2x. 1 over cos x sine x plus, so we must change our cos 2x and sine 2. So we go to our double angle formulas or double angle identities. So here it shows that our cos 2x, we can write it as cos x cos squared x minus sine squared x, or 1 minus 2 sine squared x, or 2 cos squared x minus 1. Right. When I look at my left hand side, is the one that is going to guide me for this one, of course, for cos 2x. Right. I choose to change cos 2x to 1 minus sine 2x, because if you check my left hand side, I have cos 2 sine squared x. Therefore cos 2x, I'll change it to 1 minus 2 sine squared x. Right. I chose this one because I looked at my left hand side. This is my direction. This is where I'm going. So whenever you walk, you always look at where you go. You don't just walk for direction. Right. Then we also change our sine 2x. What I like about sine 2x, the identity, it's only one. You don't have to stress for which one to choose. So I write it as sine 2x. We change it as to 2 sine theta cos theta. 2 cos x sine x. Right. We go back to instructions, right, or the steps. Right. They say that if there are fractions, find the lowest common denominator. Right. So we have a fraction. Now we can find our lowest common denominator. What is our lowest common denominator? Our lowest common denominator is 2 cos x sine x. So we write it as our lowest common denominator, 2 cos x times sine x. And we take our lowest common denominator, we multiply to each fraction. So when we multiply to each fraction here, we're going to multiply by 2 cos x sine x. Cos x sine x, cos x times sine x cancels cos x times x. We are left with 2 times 1. Right. This side. Then we multiply by the lowest common denominator this side. 2 cos x times sine x cancels 2 cos x sine x. We are left with plus 1 minus 2 sine squared x. Right. Then we continue with our algebraic manipulations. Keep on adding and subtracting. So here we have 2 times 1, which is 2. And then it's going to be 2 plus 1. You must also keep on checking your left hand side or the other side for the direction, if you are taking the right direction. So we're going to have 3, 2 plus 1 is 3, minus, we can't add 2 because this is one thing, it's 2 times. So if it multiplies, it's one thing, so you can't add 2 and 3. So it's going to be 2 sine squared x over 2 cos x times sine x. Right, let's go back to our left hand side. So if you check, our left hand side is equals to right hand side. Why? Because 2 cos x times sin x is equals to the same as 2 sin x cos x. Therefore, we must conclude. We don't leave it here. We conclude. We conclude by saying that, because if you check our steps here, the last step, end your proof with left hand side equals to right hand side. So therefore, left hand side equals to right hand side. This is the final answer. You must always conclude. Right. Thank you very much. Right. Don't forget, sometimes the question you may not have to solve your left hand side, but always check the side which is most complicated. Like for this one, our right hand side was the most complicated. Right. Thank you very much. Goodbye.